All right, let's look at a few of the kind of peculiarities of a for loop. What if my control expression was initially false? So I initialize num to 25, and I say I'm only going to run while num's less than or equal to 10. Now, this is no type of error. It's not a compile error. It's not a runtime error. There's nothing wrong with doing this. Yeah, it just basically means your loop doesn't iterate. So it goes, look what it did. It went straight to the exit point, and it printed 25. Now, what's important to note there is not only did we not print here, okay, that's why we only saw 25 once. The only print came from here, but we never used the step expression. Since the control expression was initially false, we immediately exited the loop. We didn't step to 30. 25 was the exit value in that case, okay? Now, I'm going to put that back to 100. All right, here's another peculiarity. What if we put a semicolon at the end of our loop? All right, well, what we just did was we just kind of voided the loop structure. So like this brace structure no longer belongs to the loop. The loop's going to iterate. It's going to run for 25, 30, 35, all the way up to 100. It's going to hit 105 and exit. But when it exits, it's just going to reach that semicolon because that's as far as it goes. At that point, 105 would carry here and print, and then it would also print here. And again, it's not a compile error when you put a semicolon there. It's almost frustrating. It's almost, maybe it would be nicer almost if it was, but it's not a compile error. Oh. Okay, so it's not a compile error. It's going to run, and it's going to give us exit 105, like we kind of predicted. Okay, so it actually just jumps straight to the exit value. So the moral of the story there, you probably don't want to put a semicolon there unless you had some kind of weird reason that you actually did want to just iterate a loop a bunch of times without much else happening with it. Okay? Are you allowed to initialize a variable in the initializing expression? Yes. Now, if I initialize this variable here and declare it to be a num at the same time, I can't declare num to be a variable here twice. We've seen that before with the computer, right? You're not allowed to tell the computer twice about that variable in a static context. So if I turn this line of code off, I am actually allowed to do this. Now, here's the catch. It says cannot find symbol variable num. Well, what I just did was I just localized num to the for loop. What I mean by that is its scope only exist in that purple block structure right there of the for loop. It can't be used anywhere else in the program. It's what we call a local variable now. It only can be used inside this structure here, nowhere else, okay? So what do I have to do then? Well, if I turn this line of code off, everything's fine now. Like this would work. It would print all the numbers from 25 to 100. I just won't be able to print that exit value. The way my code currently stands, I can't access num from outside of the loop. So I'd have to turn this line of code off for me to be able to run my program because of the scope issue I just created. Num is now local to that loop. If I want to use num after the loop ends, okay, I got to go back to how I had it before. I need to declare num as an int here, and then I can initialize it and use it later, and even after the loop ends, now I can go back to using it again. The difference is when you declare num to be an int right here, you've now said that that variable is local to this structure, the whole main method. See that yellow box around the code? That's where num can be used, all throughout that yellow box. After it's been declared, it can be used anywhere in the rest of that main method. That's why we don't get any type of error here. Okay, so that's something to be a little cautious of. Same thing if I did this. If I made a Boolean variable, maybe I'll call it lucky, and I'll say it's true. Okay, if I then went outside of the loop and I tried to print lucky, I'd have that same exact issue. The compiler is going to tell me it can't find it. I mean, why can't it find it? It's right there. I can find it. Why can't the computer find it, right? But it doesn't matter. The computer can only use that variable within that block of code if I declare it that way. Okay, again, this is what I call a local variable. We say that that variable's scope is only in here, inside this block. That's the only place it can be used. I can't use it outside. If I wanted to use it outside, okay, now I have to declare it outside of the code first. Now, I'm going to get an even stranger error message this time. When I hit compile, it says variable lucky is already defined in the method. Okay, well, I know how to fix that. I can't tell the computer twice. I'm going to get an even weirder one now. Variable lucky might not have been initialized. What are they talking about? I initialized it right here. Remember, I declared it here to be Boolean, and I initialized it here to be true. So what are they telling me that I haven't initialized it for? Okay, it's like we've seen with if statements and while loops. If that control expression's false on the first iteration, that means the loop doesn't run like we saw before, and it skips all of this code. And so here's the computer's thought process. Okay, you told me lucky's Boolean, and you're asking me to print it. Well, what if your loop doesn't run? I won't know what to print. And the computer's scared. It's thinking, I don't know, should I print true? Should I print false? It doesn't like that. So it just throws an error. Now, as a human, we look at this and go, computer, what are you scared of? You got 25. It says less than or equal to 100. Don't worry about it. The computer doesn't care. It doesn't check the evaluation of your Boolean, of your control expression. It doesn't look ahead to figure out if it's true or false. It just says, since you're dependent on that, you might skip this, and then I won't know what to do. So like what I'd have to do here is I'd have to actually initialize it outside of the loop so that I could use it inside the loop and then print it after. It's a little tedious. When we get out of a static context, some of these rules are going to change a little. We'll talk about that on another day. All right, now, what if I take the braces off of this loop? What's going to happen? Well, like we've seen before, you take the braces off, you only go to that first semicolon. So this loop, it's a pretty stupid loop right now, it's just going to keep saying lucky is true over and over and over. What do you think it's going to print when it gets right here? It's going to print 105. It's kind of like when I put the semicolon at the end of the loop. It's going to keep iterating until it exits with 105. So by the time it hits this, it's just going to print 105. We're not going to see it print 25, 30, 35, 40, any of those values. Okay? It only printed 105 because it didn't iterate to that print statement over and over and over. It just ran it once when it got there for the first time. There were no iterations of the print statement. The only iterations were this line of code because once I took the braces off, it just attached itself to the first semicolon. This tab does not matter. It doesn't matter that you tab that print line over. If you want that print line to belong to that loop, you've got to brace it. There's no way around it. Okay? So that's the only way to attach more than one line of code to a loop. All right, the last thing I'm going to show you, okay, we can break from a loop before the control expression kicks in, okay, like we've seen before with the switch case. So if I put in a little if statement that says if num is 60 break, I'll break the loop after 60 prints. So we're going to see it print 25, 30 up to 60. What do we think the exit value is going to be? Is it going to be 60? Is it going to be 65? Is it going to be 105? Let's find out. Okay, the exit value is 60. Now what's important to note about that is that means on the final iteration of the loop, when we hit the break statement, we immediately broke the loop and did not call the step expression. Okay, so when you break a loop, you're not going to call the step expression again. You're just going to immediately get out of the loop, and no longer will you consider anything from it. Okay, it's just like an immediate exit, basically to this brace, which leads you to this print statement. And so this time the exit value was actually 60.